In today's video, we're going to talk about graphs of inverses. So in the last lesson, we talked about inverses. And so we already know that the domain and range of inverse functions are switched with each other, that the x becomes the y becomes the x. And we went over that when we found the equations for inverse functions algebraically. On a graph, what this means is that the ordered pairs are going to have reversed coordinates. So again, flipping the domain and range, or flipping the input and the output, the x and the y. Also, there is a very quick way to visually tell if you're given two graphs and you want to know if they're inverses of each other. You can see that they are reflections over the line y equals x, and I'll illustrate that for you in one of these examples. Another thing that you need to remember from a previous lesson that will be reviewed on this quiz is that in order for the inverse to be a function, the original has to pass the horizontal line test. So horizontal line test when we're talking about inverses being functions. Okay, so example 1, based on the information given, list 4 ordered pairs that are found on the graph of the inverse. So again, the ordered pairs of inverses are going to have reversed coordinates. So even though neither of these are a list of ordered pairs, we can get the ordered pairs from them. So here, the original is -2, 3. So that means if I reverse those, I get 3, -2. Then 0, 3 becomes -3, 0. 2, -9 becomes -9, 2. And 4, -15 becomes -15, 4. So these would be the 4 ordered pairs that we know are going to be on the graph of the inverse for 1a. On 1b, we don't have a list of the coordinates, but we can see from the graph where some coordinates are. So here, and you can see on the y-axis, it's counting by 2s. On the x-axis, it does not have a scale, which implies that it's counting by 1s. So this point down here would be 0, -2, which means that I would need to go to -2, 0. So because I'm counting by 1s, that would be this point, which is already on there. This point over here is 1, 0. So when I switch those, that becomes 0, 1. So that would be right here. So notice that I'm graphing them. I'm also going to list them. So we had -2, 0. And 0, 1 so far, because we did these 2 points already. Then this point over here is -1, 0, so that becomes 0, -1. And then finally, this original point that was -2, 0 becomes 0, -2, which is right here. So these would be our list of the coordinates that we know are going to be on that inverse. And when we're talking about being reflections over the line y equals x, the line y equals x, now here it's a little bit tricky because it doesn't have the same scale on both axes, but that means y equals x has a y-intercept of 0 and a slope of 1. So if I use a different color here to start with a y-intercept of 0 and do a slope of 1, that means I'd be going up 2, right 2, up 2, right 2, down 2, left 2, down 2, left 2. This would be where the line y equals x would be. And if you flip each of these individual points over that line on the red, you end up with a point that is on the purple dots. And so that's how we can tell that those are reflections. Again, they will definitely ask you a question about this line, so make sure that you know that one. All right, example 2, based on the given graph of f of x, decide whether the inverse of f of x is a function. So again, we could draw the inverse if we wanted to, but the easiest way is what we've written here. Look at the original, decide if it passes the horizontal line test. So on A, horizontal line here touches twice. So that would mean that the inverse is not a function. Now that doesn't mean we can't find ordered pairs for it. We could list ordered pairs for the inverse. It's just that the inverse is not a function. It would just be an equation or a relation. This one, I'm drawing tons and tons of horizontal lines. None of them are touching more than once. So this one would be a yes. F prime of x is a function. And then on C, same idea, because we're always going to be using the same thing. I can draw as many horizontal lines as I want. None of them touch more than once. So this one would also be a yes. So f prime of x, or the inverse of f of x, is a function. So this one's pretty short and sweet. It's just one quiz, one section. Make sure you ask if you have questions.